A'udhu billahi minash shaitanir rajim. Bismillahir Rahmanir Rahim. Assalamu alaikum students. Significant figures. Definition: in any measurement, the accurately known digits and the first doubtful digit are called significant figures. For example, suppose that we want to measure the length of a straight line with the help of a meter rod calibrated in millimeters. Let the end point of the line lies between 10.3 and 10.4 centimeter marks. By convention, if the end of the line does not touch or cross the midpoint of the smallest division, the reading is confined to the previous division. In case the end of the line seems to be touching or have crossed the midpoint, the reading is extended to the next division. By applying the above rule, the position of the edge of a line recorded as 12.7 centimeter with the help of a meter rod calibrated in millimeters may lie between 12.65 centimeter and 12.75 centimeter. Thus, in this example, the maximum uncertainty is plus minus 0.05 centimeter. It is in fact equivalent to an uncertainty of 0.1 centimeter, equal to the least count of the instrument, divided into two parts, half above and half below the recorded reading. The uncertainty or accuracy in the value of a measured quantity can be indicated conveniently by using significant figures. The recorded value of the length of a straight line, that is 12.7 centimeter, contains three digits 1, 2, 7, out of which two digits 1 and 2 are accurately known, while the third digit, that is 7, is doubtful one. In other words, a significant figure is the one which is known to be reasonably reliable. If the above mentioned measurement is taken by a better measuring instrument which is exact up to 100th of a centimeter, it would have been recorded as 12.0 centimeter. In this case, the number of significant figures is 4. Thus we can say that as we improve the quality of our measuring instrument and techniques, we extend the measured result to more and more significant figures and correspondingly improve the experimental accuracy of the result. General rules for deciding the significant figures. Number 1. All the digits 1 to 9 are significant. However, zeros may or may not be significant. In case of zeros, the following rules may be adopted. A zero between two significant figures is itself significant. In 101, the zero is significant. B. Zeros to the left of the significant figures are not significant. For example, none of the zeros in 0.00467 or 0.259 are significant. C. Zeros to the right of a significant figure may or may not be significant. In decimal fraction, zeros to the right of the significant figure are significant. For example, all the zeros in 3.570 or 7.4000 are significant. However, in integers such as 8000 kilogram, the number of significant figures is determined by the accuracy of measuring instrument. If the measuring scale has a least count of 1 kilogram, then there are 4 significant figures written in scientific notation as 8.000 into 10 to the power 3 kilogram. If the least count of the scale is 10 kilogram, then the number of significant figures will be 3, written in scientific notation as 8.00 into 10 to the power 3 kilogram, and so on. Explanations. With the help of a measuring instrument, we can determine the number of significant figures in a measurement. For example, if the least count of a measuring instrument is 1 kilogram and the quantity to be measured is 8000 kilogram, then divide this 8000 kilogram by 1 kilogram, we get 8000 kilogram. Now this can be written as 8000 into 10 to the power 0 kilogram. Now according to the rules, there should be one digit before a point. So we can write it 8.000 into 10 to the power 3 kilogram. And in this way we can see that there are 4 significant figures in this measurement, that is 8.000 into 10 to the power 3. So in this way there are 4 significant figures in this measurement. Similarly, if the least count of the measuring instrument is 10 kilogram, then and the quantity to be measured is 8000 kilogram, then divide 8000 by 10, we get 800 kilogram. Or we can write 800 into 10 to the power 0 kilogram. Or according to the rules, there should be one digit before a point, that is 8.00 into 10 to the power 3 kilogram. So in this way, in this measurement, there are 3 significant figures. Number 2. In multiplying or dividing numbers, keep a number of significant figures in the product or quotient not more than that contained in the least accurate factor. That is, the factor containing the least number of significant figures. For example, the computation of the following using a calculator gives 1.457 68982 into 10 to the power 3. As the factor 3.64 into 10 to the power 4, the least accurate in the above calculation has 3 significant figures. The answer should be written to 3 significant figures only. The other figures are insignificant and should be deleted, that is 1.46 into 10 to the power 3. Precision and accuracy. In measurements made in physics, the terms precision and accuracy are frequently used. They should be distinguished clearly. The precision of a measurement is determined by the instrument or device being used, and the accuracy of the measurement depends on the fractional or percentage uncertainty in that measurement. For example, when the length of an object is recorded as 25.5 cm by using a meter rod having its smallest division in millimeters, it is the difference of 2 readings of the initial and final positions. The uncertainty in the single reading, as discussed before, is taken as plus minus 0.05 cm, which is now doubled and is called absolute uncertainty, equal to plus minus 0.1 centimeter. Absolute uncertainty in fact is equal to the least count of the measuring instrument. Precision or absolute uncertainty is equal to plus minus 0.1 centimeter. Then the fractional uncertainty will be 0.1 divided by 25.5 centimeter, which is equal to 0.004. Percentage uncertainty will be equal to 0.1 centimeter divided by 25.5 centimeter multiplied by 100 divided by 100 is equal to 0.4%. Thus the reading 25.5 centimeter taken by meter rule is although less precise but is more accurate, having less percentage uncertainty or error, whereas reading 0.45 centimeter taken by vernier calipers is more precise but is less accurate. In fact, it is the relative measurement which is important. The smaller a physical quantity, the more precise instrument should be used. Here, the measurement 0.45 centimeter demands that a more precise instrument such as micrometer screw gauge with least count 0.001 centimeter should have been used. Hence, we can conclude that a precise measurement is the one which has less absolute uncertainty, and an accurate measurement is the one which has less fractional or percentage uncertainty or error. Example 1.1. The reading taken with different time devices are T1 is equal to 2.5 seconds, T2 32.54 seconds, T3 is equal to 10.52 seconds. Find the total time up to correct precision. Now the total time capital T is equal to T1 plus T2 plus T3, which is equal to 2.5 plus 32.54 plus 10.52 seconds, which is equal to capital T is equal to 45.56 seconds. According to the rules discussed above, the least precise number is T1, which is equal to 2.5 seconds. Thus we round off their sum to one digit after decimal point, that is T is equal to 45.6 seconds. Example 1.2. The diameter of a solid cylinder measured with vernier calipers is 2.20 cm and its length to be 3.52 cm. Find its volume to the possible accuracy. Now the volume of solid cylinder is capital V is equal to pi r square into L, while radius will be equal to diameter divided by 2. Here it is 2.20 divided by 2, which is equal to 1.10 centimeter. Thus, by putting the values of radius and length of the solid cylinder, we get the volume equal to 13.38605714 centimeter cube. Now there are three significant figures both in radius and length. Thus the number of significant figures in the volume should not increase than 3. Therefore we round off the result to 3 significant figures, which is 13.4 centimeter cube. Now this is the day 3 assignment. You are required to solve it.